Hi, how are you? In this video, we would like to discuss some guidelines to solve more complicated equations. So the last two videos you probably watched, we learned about adding and subtracting properties of equality and then multiplying and dividing properties of equality. Well, we want to combine those ideas together to solve two-step equations and even larger equations, and we need some guidelines to do that. First, you want to simplify each side of the equation completely. So look at it as two independent algebraic expressions. Make sure the left side's completely simplified and the right side is completely simplified. Step 2, decide which side of the equation will be the constant side and which side will be the variable side. So remember, from the last problems we did, you always had to have your variable on one side and your numerical values or your constants on the other side. So we'll go through and decide which. Then we're going to collect all variable terms on one side of the equation and constant terms on the other side. Use addition and subtraction. So after you decide which side they belong on, then you'll use the properties of addition and subtraction of equality to get it the way you need it. Number 4, you make the coefficient of the variable term 1 by either dividing or multiplying by the same value on both sides. And finally, you check your work. So if you need to refer back to the guidelines, they're right here. But I definitely want you we'll use this to go through problems and work it out, okay? Okay, so what I just discussed is much better explained actually with a problem. So when we look at problem A, we're supposed to solve for variable A. So the goal is to get this A on one side of the equation by itself. Now step 1 was to simplify each side of the equation separately. So when I'm looking at the left side, that is completely simplified. I cannot do anything else with 5A plus 3 because those are not like terms. On the right side, that is also completely simplified. So step 1 is not required for this because it's already done. The next step, if we go back and take a look, step 2 says decide which side of the equation will be the constant side and which side will be the variable side. Okay? Well, the variable is already on the left side, so my advice is to keep the variable on the left side. So the variable side will be on the left, the constant side will be on the right, which means we want to get rid of the plus 3 and the times 5. Now, which do we do first? You want to undo your addition subtraction first. So I'm going to draw my line to remind me that the equal stays right there. And I'm going to subtract 3. Now, if I subtract 3 on the left side of my equal sign, I also have to subtract 3 on the right side of my equal sign. Again, don't feel like you have to use the same notation I do, but if you're having trouble with these, if you're struggling at all, I do advise that. Now the plus 3 and the minus 3 cancel, so I have 5A. I keep my equals lined up. Now here's a hint. If you have negative 37 minus 3, think about that as negative 37 plus a negative 3. If you always say plus between them and take this as your signs, like plus or positive or negative instead of subtraction, it'll be easier. So negative 37 plus negative 3 is negative 40. Okay, so I have negative 40 over here. I didn't mean that to be that color. All right, now the next step is I'm trying to get the A by itself again. It's being multiplied by 5, so to undo that, I'm going to divide each side of my equation by 5. So the 5's cancel, and I have A is equal to negative 40 divided by positive 5 is negative 8. And then we should check ourselves. I might not check the entire video, but I will check a few of the problems. And I have 5 times negative 8 plus 3 equals negative 37. We're trying to see is that true or not. Well, we multiply before we add. 5 times negative 8 is negative 40. Plus 3 is that negative 37. And it is because when you take a negative and add to a positive, you subtract the numbers and keep the sign of the heavier one, so this checks out just fine. Let's try another two-step problem. So the first thing I do is I simplify the left side if I can. Well, I can't. 3m minus 8 are not like terms. 19 is definitely already simplified. I draw the line for my equals. And the first thing I want to do is add 8. Do the opposite of subtracting 8, which is add 8 to both sides. And then I have 3m equals 27. Then I'm trying to get the m by itself. Since I'm multiplying by 3, I do the opposite and divide by 3. So now I have m is equal to 27 divided by 3 is 9, which that's my solution. When I go to check, I've got 3 times 9 minus 8. Does that really equal 19? Well, we know 3 times 9 is 27 minus 8. 27 minus 8 is 19. So 19 equals 19, and it checks. Now problem C here looks a little different than the last two problems that we did. The first step is to simplify each side. Well, the left side is completely simplified. The right side, those are not like terms. I can't do anything else there. Step 2 says decide which side is going to be the variable side and which side is going to be the constant side. Look, I've got variables on both sides. Now, here's my advice. Because this is only a single variable, it doesn't have a constant. Okay, it doesn't have like a +2 or something like that. Let's let this be the variable side and this side be the constant side because there's already a constant over here. So that means the negative 7x, we've got to get rid of it. Well, what do I do to get rid of it? So first, your imaginary equal sign down the middle. I'm going to add 7x. I'm going to add the entire. Why did I add? Because it was minus right here, so I'm doing the opposite. So the negative 7x and the plus 7x cancel. I still have an equals down the middle and a negative 1 on the right. Now negative 6x plus 7x is going to be 1x, or another way to say that is just x equals negative 1. There's no more solving to do since that's already x isolated. Now to check it, I'm going to try to do that in green. So is negative 6 parentheses negative 1 for my x minus 7 parentheses negative 1 for my x again. Are they the same? Well, negative 6 times negative 1 is 6 on the left. On the right, we've got negative 7 times negative 1, which is positive 7 minus 1. Well, sure is. It matches, right? Now let's try it again. Same story, just a different problem. I have a variable and a constant on the left, and I have just a variable on the right. So if we decided to subtract 8m on both sides and make our right side our variable side and our left side just our constant side, that would be the fastest way to do it. Although you would be okay to subtract 5m, but then you still have to move the minus 9. So let's line up, there's our equal line, subtract 8m on the left and subtract 8m on the right. Notice that's once on each side of the equal sign. The 8m minus 8m cancels. On the left I have 9 equals, and over here 5m minus 8m. Those are like terms, right? So it's minus 3m. Now I'm trying to get this m by itself. Okay, so I want to leave the m alone at this point. Now I'm trying to get the coefficient to be a 1. So I've got to get rid of this negative 3 being multiplied. I'm going to divide by it. And then negative 3's cancel. So on the right I have m, and on the left 9 divided by negative 3 is negative 3. And we check our work. So I have 8 times negative 3 plus 9 equal to 5 times negative 3. The question is that true? So 8 times negative 3 is negative 24 plus 9 equals to negative 15. Negative 24 plus 9 is negative 15 equals negative 15. That checks out. And so we know we did it right. Okay, next. Now, simplify each side again. We still haven't done a problem that actually requires simplification. And we won't on this page either because the left 8h is completely simplified and these are not like terms. But we do need to decide what side we want our variables on. And since the right side has variable and constant, I'm going to make the left side that's just got variable on it the variable side. So what am I going to do that? I've got to move the minus 4h. To do that, I need to add 4h to both sides. You're always doing the opposite. If it says minus 4h, you add 4h. If it said plus 4h, you would minus 4h. Okay? 8h plus 4h is 12h. Those are like terms. Minus 4h and plus 4h cancel equals 12. That was already there. Now I've got to get this h by itself. Right now it's being multiplied by 12, so to undo multiplication, I divide both sides by 12. That gives me h is equal to 1. Again, to check our work, I have 8 times 1 equals negative 4 times 1 plus 12. That's 8 on the left. Negative 4 plus 12 is also 8 on the right, so it checks out just fine. Now on this side, we've got some decisions to make because, look, the left side has a variable and a constant, and the right side has a variable and a constant. So that means that it's up to us. Do we want the variable on the left and the constant on the right, or vice versa? Now, I do have some advice along the way. We can subtract 7y or we can subtract 9y. But if we subtract the smaller one, we're left with positive numbers. So I'm going to minus 7y and minus 7y. Okay? Which means what I'm trying to do is get my variables on the left and my constants on the right, because I'm essentially moving this one over here. Okay, 7y's are gone. See, now I just have a 12 on the right. But 9y minus 7y is 2y, and I still have plus 4 on the left. So my goal is to get this y by itself, so I now have to minus 4 on each side of the equal sign. The 4's cancel, so I have 2y is equal to 12 minus 4 is 8. Now I divide by 2 on each side because that 2 is times y, so to get rid of that, I divide by 2. Alright, and then now I have y is equal to 4, and that's my solution. Again, good habit to check it. So 9 times 4 plus 4, is that equivalent to 7 times 4 plus 12? That's an easy one. 36 plus 4 is 40. On the other side, 7 times 4 is 28 plus 12, and that's 40 as well. So we know we did it right. Now this really is a page of, just like the last problems you did, it's probably worth to solve it. It's probably worth it to pause the video, solve them on your own, and then go back and see if we match. So hopefully that went well. There's my equal sign. Now I'm checking to make sure this doesn't need simplifying, nor does the right, so we're good there. My next move is to decide what side do I want my variables to be on and what side do I want my constants to be on. And since 7y is bigger than 1y, let's let the variables be where the bigger one is, the 7y, which means I need to subtract y from each side of my equation. So 7y minus 1y is 6y. The minus 3 is still there. And then this y's cancel, gives me 3. Now I'm at what we call a two-step problem. And when you get to the two-step problem, you just add or subtract whatever's required. We needed to add 3. The opposite of minus 3 is add 3. Those cancel, so I have 6y is equal to 3 plus 3 is 6. And the last step always is divide by the coefficient of the variable. So divide by 6, divide by 6. So I have y is equal to 1. And then I can check it. I didn't leave myself a lot of room to check, did I? So 7 times 1 minus 3, is that equivalent to 1 plus 3? Well, 7 times 1 is 7 minus 3 is 4. Is that equivalent to 4? Sure is. We're good. Okay. Now again, I've got to decide what side do my variables want to be on, what side do I want my numbers on. And the bigger coefficient for the variables on the right, so let's let our right side be the variables, which means when I do something on both sides, I want a minus 4a minus 4a. And what that does is put all my variables on the right-hand side. So 4a minus 4a is gone. I'm left with negative 1 equals, now 7a minus 4a is 3a, and then we still have a plus 17. Now my goal is to get this a, isolate this a, which means I have to subtract 17 and then I have to divide by 3. So let's subtract 17, because that's always the next step. Negative 1 plus, remember we have that cute little method where we can just say plus in between those, and that would give us negative 18 equals, and then this is 3a. So now I divide each side by 3. Negative 18 divided by 3 is negative 6 is equal to a. I need to check my work. So 4 times negative 6 minus 1, is that equivalent to 7 times negative 6 plus 17? That's negative 24 minus 1, which is negative 25 on the left. 7 times negative 6 is negative 42 plus 17. Remember, when they're opposite signs, you subtract and you keep the sign of the larger. So 42 minus 17 is 25. And the 42 is the heavier one, and it's negative, so negative 25. So this checks out for us. Fractions. Now, I do want you to keep in mind that I have a method for dealing with fractions coming up, but they trickle them in along the way, and turns out this fraction problem is not as scary as it might look in the beginning. Now, notice that there's no simplifying to do on the left or the right. We don't have like terms. So we've got to decide what side is our variable side, what side is our constant side. And the variable side is usually the one with the bigger coefficient. So 7/6 is bigger than 1/6, so I'm going to subtract 1/6 x from each side of my equation using the subtraction property of equality. So those cancel. 7/6 minus 1/6 is 6/6 x plus 11, and that equals to 8 on the right. Now we know 6/6 is 1, right? So that's really just x plus 11 equals 8. So all I really have to do next is subtract 11 from both sides to get this x by itself. So those cancel. X is equal to 8 minus 11, or either 8 plus. Remember, we talked about you can always say plus and take that as a sign with the 11. So 8 plus a negative 11 is negative 3. So my solution is negative 3. Now I'm going to check it. So 7/6 times negative 3 plus 11. They're telling me that should be equivalent to 1/6 minus 3 plus 8. I have a feeling the check is going to be worse than solving the problem. So first thing I know is a positive times a negative is a negative. Okay, so that answer is negative. Now this negative 3, remember it's over 1. I can cancel this 3 and this 6 to leave a 2. So I have negative 7 times 1 is 7 halves plus 11 equals, now over here, this negative 3 is over 1. This positive times this negative is a negative. And then this 3 and this 3 and 6 leaves a 1 and a 2. So 1 times 1 is 1, over 2 times 1 is 2, plus 8. Now my next issue is I don't have a common denominator. Okay, so this 11's over 1, I need it over 2, so I'm going to multiply by 2 over 2. Now I have negative 7 over 2 plus 22 over 2, which is going to give me 15 over 2. That's the left side. Now on the right side, I have the same issue. This 8 is over 1. I need it to be over 2, so I got to multiply by 2 over 2. And that gives me negative 1 over 2 plus 16 over 2, which is 15 over 2. Notice it checks. But that check was probably more trouble than we really needed it to be. Okay, for our next problem, we just have decimals to deal with. So we need to, once again, decide which side is our variable side, which side is our constant side. And it doesn't matter, except for the one fact that if you let your variable side be the one with the larger coefficient, then you wouldn't have to deal with negative values. So I'm going to subtract 1.2y from both sides of the equation. So it's gone from the right side completely. 3.6 minus 1.2, or 3 6/10 minus 1 2/10, is going to be 2.4y, or 2 4/10, plus 8 is equal to negative 4. Now it's what we call a two-step equation. So I need to subtract the 8, because remember I'm trying to move values away from the y. So I subtract 8 from the left side of the equation, subtract 8 from the right side of the equation. The 8's cancel, but I still have 2.4y is equal to, now remember the trick, when you have negatives, you can always just say plus in between. So negative 4 plus a negative 8 is negative 12. and we divide each side by the coefficient of the variable. So I'm dividing by 2.4. So just use your calculator to do negative 12 divided by 2.4, and I get negative 5. No, the y doesn't go there. Y'all, I just need the 2.4. So I get y is equal to negative 5. Now we can check it easy enough, especially if you're using a calculator. So you have 3.6 times negative 5 plus 8. Is that the same thing as 1.2 times negative 5 minus 4? And 3.6 times negative 5 is going to be negative 18 plus 8. On the other side, 1.2 times negative 5 is negative 6 minus 4. On the left, negative 18 plus 8 is negative 10. On the right, negative 6 plus, you can always say that, a negative 4 is also negative 10. So that problem checks out fine. Well, what if we have to use the distributive property? That's no big deal, right? We just multiply. Remember, how do we know to use the distributive property? Anytime you have a number, right outside a set of parentheses like that. And also, you can't add what's in the parentheses together because they're not like terms. Then the distributive property is what you need. So 5 times x is 5x, and 5 times 3 is plus 15, and on the right we still have 30. So this is one of those problems that you have to do step 1, which is simplify each side, and that includes using the distributive property. Now we decide what is our variable side, what is our constant side. Well, clearly the left side is our variable side because there are no variables on the right. So I'm ready to go ahead and subtract 15 from each side. Now on the left, that leaves me with 5x. On the right, 30 minus 15 is 15. Then you divide by the coefficient of the variable, so divide by 5, and that gives me x is equal to 3. When I go to check my work, I have 5, parentheses, 3 plus 3. Is that really equal to 30? And you might see right off the bat it is, right? That's 5 times 6 equals 30, and it checks out. The next one, very similar, 6 times y is 6y. And then 6 times, think about that as a negative 3. 6 times negative 3 is negative 18 equals negative 24. Now, which is our variable side? The left side, because it's already on the left side, and our constant is on the right, which means I need to add 18 to get rid of the minus 18. So now I have 6y is equal to negative 24 plus 18 is negative 6. And then divide each side by 6, so y is equal to negative 1. My next step is to substitute negative 1 into my equation, so negative 1 minus 3 is equal to negative 24. Is that true? You know negative 1 minus 3, or think about that as a negative 1 plus a negative 3 is negative 4. 6 times negative 4 is negative 24, so yes, that definitely equals negative 24. Now, if you'll notice here, it looks like we just have a negative in front of parentheses, but really that's implying there's a negative 1 to distribute. So I have negative 1 times z is negative z, and negative 1 times 7 is negative 7 equals negative 15. So we have simplified each side. Now I want to do this as a two-step problem, which means I'm trying to get the z by itself, so I add 7 to each side of my equation. That gives me negative z is equal to negative 15 plus 7 is negative 8. But now I've got to get rid of this negative in front of the z. Now again, remember like we said a minute ago, there's really a negative 1 right there. So what I'm going to do to get rid of the negative is divide each side by negative 1. So that negative 1 cancels with that one, and I have z is equal to negative 8 divided by negative 1 is 8. So my solution is 8, and we should probably check it. So I have negative, and this is 8 plus 7 is equal to negative 15. Now what do you think? Is that true? Well, we know 8 plus 7 is 15, and that's a negative, so negative 15 equals negative 15. Yeah, that's true. On the next problem, I distribute the 7 inside, so I have 7n minus 21, and then the minus 8 is just sitting out there by itself, equals negative 15. Now here I have like terms that I can combine together. So now I have 7n. Now negative 21, and I'm going to use that trick again all the time. When I have minus, I'm just going to say that's plus a negative. And negative 21 plus a negative 8 is negative 29 equals negative 15. Now I have my two-step problem, so I add 29 to each side of the equation. And I'm left with 7n equals negative 15 plus 29. Remember, you subtract, and you keep the sign of the bigger one, which is positive. Last step is always to divide by the coefficient of your variable. So divide both sides by 7, and I get n is 2. Now, is that right? Well, let's check. So 7 times 2 minus 3 minus 8, is that equivalent to negative 15? We know 2 minus 3 is negative 1, so 7 times negative 1 minus 8. I'm going to work to the right. That's negative 7 minus 8, which you could also say is negative 7 plus a negative 8, which is definitely negative 15. Now, I know I've promised you several times that I have an easier way of dealing with fractions, and that is a video coming up, and I believe it's the next video coming up. But we haven't learned that technique yet, and actually in this problem we don't need it. But I just want you to not have a fear of fractions. We've got a way of handling it. Now, if that was any number, the next step would be to distribute, right? So that's what we're going to do. So I have 2/3 times 9x. Minus 2/3 times 12 equals 8 plus 2x. Now notice I didn't even multiply that out. I just wrote down exactly what we have. 2/3 times 9x minus 2/3 times 12. Now we can multiply it out. Now how do you multiply fractions? You multiply numerator times numerator, and then denominator times denominator. And you need a fraction, right? So I just put my whole values over 1. And also, I can simplify. This 3 and this 9 have a common factor of 3, so that turns into a 1 and a 3. And 2 times 3 is 6. The x just carries over, and in the denominator, 1 times 1 is 1. And we don't have to keep 1s in the denominator, minus. Now, 3 and 12 have a common factor of 3, so 3 goes into 3 once, into 12 4 times. And I say 2 times 4 is 8. And in the denominator, 1 times 1 is 1. And again, we don't have to write that 1. Equals 8 plus 2x. All right, so we have simplified the left-hand side. The right-hand side we couldn't do anything with. Now, if you'll notice, we have variables on both sides of our equation. I have a 2x over here and a 6x on the left. So we've got to decide which side we want our variables to live on. And the larger of the two coefficients is probably the smartest place, which would be the left side. So I'm going to subtract 2x from each side of my equals. All right, 6x minus 2x is 4x. The minus 8 comes down, and then I have equals 8. So now I have a two-step problem. So I'm ready to add 8 to both sides to get this x by itself. That gives me 4x is equal to 16. And the last step is divide by the coefficient of x, which is 4, so x is 4. I have some room over the right to check it. So I have 2/3 times 9 times 4 minus 12, all in parentheses, and it is equal to 8 plus 2 times 4. So that gives me 2/3. Now 9 times 4 is 36. 36 minus 12 is 24, equals to 8 plus 8. Now we don't know if this is equal or not, but we'll find out. Now that 24, since I'm multiplying a fraction times another fraction, I'm going to put him over 1. And 3 goes into 24 8 times. 3 goes into 3 once. 2 times 8 is 16 over 1 times 1, which is 1. Does that equal to 8 plus 8? Well, it sure does, so we know we did it right. Now to recap, the very first step is to simplify each side. So it's like it's two separate problems. Now the right side, there's nothing we can do with that. But the left side, there's a lot going on here. Now we need to distribute. We know there's an 8 times that needs to go inside. But listen, let's take this as a negative 8. Okay, go ahead and take that with the 8. I promise it will be easier. And it is okay. So the negative 6 in front, I'm just rewriting it. Now I have negative 8 times k is negative 8k. And negative 8 times negative 2 is plus 16 equals negative 10. Now I have like terms to deal with. So what do I mean by that? Well, I have a negative 6 that I can combine with this positive 16. Those are like terms because they're both constants. So negative 8k, I'm just going to rewrite. Negative 6 plus 16 is plus 10 equals negative 10. Now, you'll notice I only have a k on the left, so this is going to be my variable side, is the left side. My constant side is going to be on the right, so that means I need to move this constant to the other side. So I'm going to subtract 10 from both sides. So this positive 10 and this negative 10 cancel. That leaves me with negative 8k on the left. Now careful here, again, that trick that I keep doing, if you always say plus and take this instead of subtract 10 or minus 10, think about that as negative 10 plus a negative 10. You're in a much better place. So that's negative 20. A lot of people would put 0 for that, but it's not. It's negative 20. The last step is to divide by the coefficient of the variable, which is negative 8 in this case. So I have 8k equals, now these two negatives cancel, don't they? Negative divided by negative is a positive. And 20 over 8 reduces as well. 4 divides into both the numerator and denominator. So divide each of these guys by 4. So I have 20 divided by 4 is 5. And 8 divided by 4 is 2. So k is equal to 5 halves. Now, a lot of students get really nervous when they get a fraction as an answer, and it's worth checking your work, but there's nothing wrong with a fraction as an answer. It happens all the time. So negative 6 minus 8, 5 halves in place of my k minus 2, does that really equal negative 10? Well, let's find out. So negative 6 minus 8, by the way, you cannot do that operation because multiplication comes before subtraction. And what I have to do is I have to find a common denominator to do this subtraction right here. So my common denominator is 2, right? So I need to multiply this 2 by 2 over 2. So I have negative 6 minus 8. And that's going to be 5 over 2 minus 4 over 2. So that's negative 6 minus 8. And that's going to be 1 half. Now I can multiply. 8 times 1 half is 4, or you can think about it as 8 over 1. And this 2 and this 8 have a factor of 2 in common, so that turns into a 1 and a 4. So this is negative 6 minus 4. Finally, you can think about this as negative 6 plus a negative 4, like that, which definitely gives you negative 10. And way over there, straight down, checks out. Now all that's happening is these problems are just getting a little bit bigger where you have to simplify more before you solve. But when it comes to solving, the steps are really the same. So look at this 8 parentheses m plus 1 minus 5. Let's simplify all that completely and then simplify all that completely on the right, and then we'll talk about solving. So 8 times m is 8m. 8 times 1 is plus 8, and bring down the minus 5. And then I'll keep working on the left, and then we'll work on the right. Now, like terms, right? 8m doesn't have another like term, but 8 and 5 are constants, so we can subtract 8 minus 5 is 3. So on the left, I have 8m plus 3. Now on the right, let's do the same thing. 3 times 2m is 6m. And 3 times, think about that as a negative 4, is minus 12, and then this minus 1 is just on the outside. Now, once again, I have like terms right here, so it's 6m. Now, think about saying plus in between. Negative 12 plus negative 1 is negative 13. Now what I have is an equation that I can start solving. You've got to decide which is your variable side and which is your constant side. And the variable side, let's let it be the one with the largest coefficient, so the left side, which means I subtract 6m from each side of the equation. So that cancels. So I apologize for that. My computer freaked out there for a second. So 8m minus 6m is 2m plus 3 equals, and the 6m minus 6m cancels, minus 13. right? So now I have a two-step problem. I've got to get rid of that plus 3, so I'm going to subtract 3. Then I got to get rid of that multiply by 2, so I'll divide by 2. So I subtract 3 here, subtract 3 here. So I have 2m equals, now, that trick again, negative 13 minus 3 is easier to think about as negative 13 plus a negative 3, which is negative 16. Divide each side by 2 to get rid of the coefficient of multiplying by 2. So that gives me m, and we know negative 16 divided by 2 is negative 8. And now I check my work, and that's what makes these videos take longer than they should, is checking, but I cannot emphasize the checking enough. I mean, how powerful is that to know you can get every problem right by just checking it? So 3 times 2 times negative 8 minus 4, and then a minus 1 on the outside. And also you get good practice with order of operations, because the next thing I have to do is this right here, right? What's in parentheses? So I have 8. We know negative 8 plus 1 is negative 7 minus 5. I'm going to continue with the left side and then do the right. 8 times negative 7 is negative 56 minus 5. And again, I get to use that trick one more time. Plus a negative 5, which gives me negative, what's that going to be, 61? Okay. Now let's try the right-hand side. So again, order of operations says I have to work in the parentheses first. Even inside those parentheses, I need to multiply before I can subtract. So I have equals negative 3. That's negative 16 minus 4 with a minus 1 on the outside. So it's negative 3 times negative 20, which is negative 3 times negative 20. Oh, that's not a negative. I noticed an error, but that's me getting lazy writing an equal sign. Okay, there's an equal, so that's a positive 3, just like in the problem, positive 3. So that's negative 60 minus 1. Again, that neat little trick of when you have a minus, just think about it as plus a negative, which is going to give us a negative 61. So that means we did our problem correctly. Alright, so we have a big problem here. You see large just in size, but it's all about simplifying each side completely. So what we have to do is we have to start within. Notice there's brackets and there's parentheses. Now if I look at the parentheses, there's no work to do inside there because those aren't like terms. But I can handle this. So what I'm going to do first is I'm going to distribute the negative 5 inside the parentheses. Everything else I'm going to rewrite. So I have 12 and I have a bracket. This is 1. Comes straight down. Now negative 5 times 4z is negative 20z. Negative 5 times negative 1 is plus 5. Now let's simplify that completely and then we'll take a look at the right side. So I have 12 bracket. Now this 1 and this 5, those are like terms. So I can say that's 6 minus 20z. Finally, this 12 is really times because there's nothing between the 12 and the bracket. So I have to distribute again. 12 times 6 is going to be 72. Okay, I'm trying to make that bigger than it was. And then 12 times negative 20z is minus 240z. And that side is completely simplified. Now I'm going to start looking at the left side. On the left side, I can multiply 3 times 24 and then 3 times 11z. So 3 times 24, I do believe is 72, but let me check it just to be sure. It is. So 3 times 24 is 72 plus, and 3 times 11 we know is 33, and don't forget the z. And it can't be simplified further, so actually I'm just copying it 2 more times so I can line up again with where I am on the left side. Now our next issue is we have z's on both sides of our equation. I have a 240z negative on the left and a positive 33z on the right. Now the bigger of those two is actually the positive 33z because it's positive. So what I want to do is I would like to add 240z to both sides of my equation. Okay, so it cancels on the left and I just have 72. And on the right I have 72 plus. Now 33 plus 240 is going to give me 273Z. Notice I didn't have it lined up correctly, but that's 273Z. Now remember, what I'm trying to do is leave the Z alone and move everything else. So the next thing I'm going to do is subtract 72. So I have 0 equals 273Z. Now that's weird, isn't it? But it's right. So the last step, remember, is you divide by the coefficient. So I divide by 273. Well, 0 divided by 273 is just 0. So Z equals 0. And we can check it. So 12 times 1 minus 5 times 4 times 0 minus 1, is that equal to 3 times 24 plus 11 times 0? So I have 12 times 1 minus 5, and 4 times 0 is 0 minus 1 is negative 1. That's 12 times, now this negative 5 times negative 1 is plus 5, so 1 plus 5. That's 12 times 6. 12 times 6 is 72. So the left side's 72. The right side's hard to see. I was running out of space. But that's 24 plus 11 times 0, which is 3 times 24. And 3 times 24 is 72. So this checks out. It's our last problem. Okay? So step 1, let's simplify each side as much as we possibly can. Step 2, decide which side we want our variables on, which is m in this case, and which side we want our constants on. Step 3, start doing the work to get the variable on one side and the constant on the other. Alright, so I'm noticing here I've got 0.15 or 1500ths right next to parentheses, so that means I need to distribute. So I'm going to use my calculator to multiply 40 times 1500, so 40 times 0.15. And that gives me 6. But there's also an m right there. And I'm also going to multiply 0.15 times negative 120. So 0.15 times 120 is 18, but since it's a positive times a negative, that's minus 18. That cannot be simplified further. I'm going to do the same thing on the right by multiplying 0.5 times 60. Now 0.5 is a half of 60 is 30, so that's 30m. And 0.5 times 12, again, 0.5 is a half of 12 is 6. Or just use your calculator. Now what do? Well, I decide which side I want my variable m to live on in the end. And if you pick the larger of the two coefficients, it can make your life easy. 30 is the larger, so I'm going to leave the 30 alone and move the 6m. So minus 6m, minus 6m. You notice that's on each side of the equation, not 2 over here. Now those cancel, so I have negative 18 is equal to 30 minus 6 is 24m plus 6. Now I have a different objective. I've got my variables on one side. I'm trying to get my constants on the other. So that means I've got to move this minus 6. So I'm going to minus 6, minus 6. So think about the little plus between these. Negative 18 plus a negative 6 is negative 24 is equal to positive 24m. My very last step always is divide by the coefficient in front of the m, so divide by 24, divide by 24. We know a negative divided by a positive is always a negative, and 24 divided by 24 is 1. So my answer is m is equal to negative 1. And now I'm going to check it. So I have 0.15 times 40 times negative 1 minus 120. Is that really equal to, and I'm running out of space, so let's just do the left side first and then we'll do the right. So 0.15, 40 times negative 1 is negative 40, subtract 120, so that's 0.15. Negative 40 minus 120 is negative 160. I use that little plus in the middle there. And then 0.15 times 160 is 24, and a positive times negative makes that negative 24. That's the left. Now at the top of the page in blue, let's do the right side. So that's 0.5, that's a 0, times 60 times negative 1 for my m value plus 12. I've got to do this first. Okay, so that's 0.5. 60 times negative 1 is negative 60 plus 12. That's 0.5. Negative 60 plus 12. You're adding a negative and a positive together, so you subtract. And that's going to give you 48, but negative because the heavier one's negative. And half of negative 48 is negative 24. So it checks out. So I hope this helped you out. I know they got more and more difficult, but the steps are the same. What it comes down to is simplify each side completely. Get all your variables on one side, your constants on the other. And the very last step is just to divide by the coefficient of the variable. Hope you have a great day.